Hello, these are the exercises for Chapter 3, Section 5. So according to QSR magazine, Chick-fil-A has the best accuracy of drive-through orders, with 94% of all its drive-through orders filled correctly. The manager of a competing fast food restaurant claims that her drive-through is more accurate than Chick-fil-A. In a random sample of 224 drive-through orders, 216 were correct. Use the alpha equals 0.01 to test the claim. Okay, so we're doing this hypothesis test, and we have to go through and do our steps. So the first step is to state the hypotheses. So our parameter of interest here, see right here, it's looking at as a proportion. It tells you your sample proportion, which is 216 out of 224. So our parameter of interest is going to be P. And the status quo, what we're assuming to be true until we have evidence otherwise, is that this proportion is the same for all, and it's 94%. But the claim that they want to find evidence to support is that it is more accurate than Chick-fil-A. So they want to claim that their proportion is more than the Chick-fil-A accuracy. Then the next step is to check our requirements. So the first requirement is that there's random. It is random. So it actually states it's a random sample. So that is satisfied. Okay. The second criteria is that the sample size is less than or equal to 5% of the population size. So we have our sample size is 224. And I want this to be less than or equal to 5% of my population size. So I divide by 0.05 on both sides, and I get that 4,480 is less than or equal to n. That might be easier to see as the population size has to be greater than or equal to 4,480. Okay, so let's think about what this population is, and then see if the population size is greater than that. So here, it's going to be the drive-throughs orders at this competing fast food restaurant. So do you think that they're going to have, as long as there's more than 4,480 drive-through orders in its entirety of this competing fast food restaurant drive-through orders, then that will be satisfied. Then this third criteria is that NP naught is greater than or equal to 10. So N, again, is our sample size. So 224 times P naught, which is our proportion that we're assuming to be true in the null hypothesis, which is 0.94. And that equals 210.56. And that is greater than or equal to 10. So that criteria is satisfied. And then similarly, we also have to check that n times 1 minus p naught is greater than or equal to 10. So my n is, again, sample size 224 times 1 minus 0.94, which equals 13.44, which again is greater than or equal to 10. So our requirements is correct. So now we can go through and do a z-test for proportions. Okay, so we're going to go through and compute the test statistic and the p-value to compare to alpha and decide whether we are going to reject h-naught or fail to reject h-naught. So let's go to GeoGebra, and we will get to our probability calculator. Okay, we come to statistics, and our criteria said that we could do a z-test of a proportion, so we have to go down to there, and then we want to fill in these areas. So my null was that my p was equal to 94%. My alternative was that my p was greater than 94%. So on GeoGebra, we choose the greater inequality. Then we want to know the number of successes and then our sample size. So in our video, we had 216 were correct. Those are our successes out of our sample size, which is 224. So we're going to go through here and say 216 out of 224. And our result is down here below. Our Z is our test statistic, and our P is our p-value. So I want to write these down on the other sheet. Okay, so my test statistic was Z, and that was 1.5305, and my P was 0.0629. So again, this test statistic is how many founded errors away from the mean is our sample data, and then our p-value is the probability of being more extreme on the sample data, assuming the null hypothesis is true. Okay, so I want to compare to your p-value to your alpha. My p-value is 0.0629. My alpha is 0.01, and my p-value is greater than my alpha. So I am going to fail to reject my null hypothesis. Okay, so my conclusion is I'm going to fail to reject my H naught, and that means that we don't have enough evidence to believe anything other than the status quo. We are not rejecting the null hypothesis. So that means that there is insufficient evidence to conclude this claim that the fast food manager was making. So I'm going to give us a little more space. Okay, and there is insufficient evidence to conclude that the proportions of drive-through orders at this restaurant is more accurate than Chick-fil-A. Okay, because that is the claim that the manager wanted, that her drive-through is more accurate, and we had insufficient evidence to support that. All right, let's go to the next exercise. So in 2000, 58% of females 15 and older lived alone, according to the U.S. Census Bureau. A sociologist tests whether this percentage has decreased today by conducting a random sample of 500 females and finds that 265 are living alone. Is there sufficient evidence at the alpha equals 0.05 level of significance to conclude the proportion has decreased since 2000? Again, first step, our hypotheses. So our parameter of interest is proportions. We have a percentage here of females. We have a number out of a total. So we have proportions. What we're assuming to be true is that 58% live alone. However, we want to test the claim, and that's in our alternative hypothesis, that our proportion has decreased. So it's less than or equal to 0.58 since 2000. Okay, so we're going to check our requirements, that we are random. So this sociologist did a random sample, so that one is satisfied. Then we got to go through and check criteria 2. So our sample size, which is 500, is less than or equal to 5% of my population size. So we go through and divide by 0.05, and you get that n has to be greater than or equal to 10,000. Okay, so now you got to think about what is our population, and is that population greater than or equal to 10,000? So if our sample is of females, these 500 females that are 15 or older, then our population is going to be all females 15 years or older in the US. So there are more than 10,000 15-year-old or older females in the US. And so that is satisfied. Okay. This last criteria is that n, which in this case is 500, times p naught, which is our p in our null, so 0.58, that has to be greater than or equal to the 10. So it equals 500 times 0.58 equals 290. And that's greater than or equal to the 10, so that is satisfied. And then similarly, we have to have n, which again is 500 times 1 minus p naught, so 1 minus 0.58. And that has to be greater than or equal to 10. And that is 210, which is greater than or equal to 10. So that is satisfied. And now because these criteria are met, we can go through and do our z-test for proportions. So we want to compute the test statistic and the p-value and compare it to alpha. So again, we're going to go to GeoGebra. And our p was 0.58. That's our null hypothesis, that our proportion was equal to 0.58. Our alternative was that we were less than 0.58. So we had to change to less than. And the number of successes, we had 265 out of 500. And so with that, our results are down here where we have our z, which is our test statistic, and our p, which is our p-value. So we have our test statistic. And that equals a negative 2.2653, our p-value, and that equals 0.0117. You compare your p-value to your alpha. And your p-value here is 0.0117. My alpha in this problem is given to me as 0.05. My p-value is less than my alpha, and so therefore I'm going to reject my null hypothesis. Okay, so I have sufficient evidence. I'm rejecting the status quo because I have sufficient evidence to conclude that my claim was true. And was my claim that there is sufficient evidence to conclude that the proportion of females 15 years or older has decreased. Living alone, so that 15 years or older living alone has, I'm going to get some more space, has decreased since 2000. So the proportion of females 15 years or older living alone has decreased since the year 2000. We have sufficient evidence for that now with this test. Okay? All right, thank you.